Assalamualaikum and hi everyone. So today I want to show you how to make a mini project tool for the capacitor transient. So as we see here, that which is VOE time T and tau is per RC, and so we have done calculate, and so we get a value here, and RC for this, RC2 and RC3. So we go to that measurement by using multisim, and as you can see here, we are getting the value here and here. So and two series capacitor just like this, and this is a graph, and so on. Okay, so today I will show how to make a transient capacitor by using the multisim. So we go here. Okay, as you can see, it's a 2 series capacitor with a 100 kilo ohm resistor, and firstly we need to get the pulse voltage here. So pulse voltage here that we set is 12 volts, and the pulse width 240 and 418. So because I do this is 240 for the second for the charge, and 480 the total for the transient for charge and discharge. So as you can see here, in the 12 volt the charge we charged 12, and after the 240 it will be discharged until 480. Okay, if I run this, so as you can see here, this is a V3. V3 here is not important and we untick. And as you can see here, this is a graph for the transient capacitor, and for more detail we will get the setting for this, and I will get to 0 for the start and 14 for the last, and the total tick is 14 and minus is 1. So bottom at this just like this. So this is a time 480, and the total tick 418 divided by 12 that we get is 24, and the minus tick is 1. We get the 1 because if we get the 2, the pulse for the time for 480 is 40. So if we get 1, we can get the 20-second step here. Okay, so we get it apply. Okay, so as you can see here, it's a 14 volt and 480 for the time. And okay, we will show more detail about this, and we use black and white. It's more clear for me. And okay, if we want to get the graph here, what is the voltage, so what I need to do is, so there's a show cursor here, is a V2, and if we get a set value for 16 by an example here, and so here this is a intersection between the graph and the cursor. So we want to show the label data cursor is, I just want to tick this, and we get 11.0959. okay, and if we want to get the discharge here, this is a climax for the charge, and so if we get a 240 for the climax, okay, at the level cursor, so we get a 11.998 volt. So we round about 12 here. And if we want to show see the discharge value here, I take the 216 by example, and data for the level cursor, so we get a 513 to 522 volt, and I will round about 5.35 volt here. So after we getting this by 20 until 418 the value. So we need to transfer, or we get the data to the table and get the graph. So as you can see here, we don't get any 418 value here after discharge. So for my accuracy, I want to show you the value for 4x0. Okay, you see here, and show that the local cursor that we get is 310.5913 micro. This is still a value, but randomly is a 0. So as you can see here, the transient will be get 0 and the ampere will rise after. When the transient capacitor is charged, the current will get 0. So it's a theory for the transient capacitor. And so if we get to the, if you want to export to Excel here, you just click this, and or you want to make get a value from here, just okay, is also right. It's nothing to change here. And if you want to export to Excel, you need to use a formula by using forecast and so on if you want to get the value. So if we get to the Excel here, by example, I will get to 100k parallel. So I get the two parallel capacitor by the VC charge here. So how I get this graph is, I just take this and take a graph here, and this line graph, and I get the data here. So series name is voltage. Actually this is the name series for the edit in the name series, but I will get the example for here. And this is value. So value here we get from the 0 until 240 for the charge. Okay, I will get the charge. I will get the graph just like this, behind the discharge. So we'll get from 0 until 240. Okay, and as you can see here, this is 12 for the last, and 1 2 3 4 5 6 7 until 13 is the time. So I don't want to use the 13, the X is like this, so I did, and I go to the 240 here, and okay. So as you can see here, this is 0 until 240. I will get okay and change the graph by that anything I like. And yeah, this is the value for this. And as you can see here, the Excel, if you small like this, you get the roundabout for this value for here. Okay, and if you go more big, and you get the point more detail here, so it doesn't matter here, but I will show that. Okay, this is for the charge for the transfers. And if you want to get discharge, so we get back here, and this is graph. So this is a blank graph, we put the data here, and we get add, and just an example, capacitor discharge. Okay, this is for the discharge. So we gather here after 214 until 480. Okay, I want to get from the 240, because this 240 is a climax for the voltage, and until 480. Yeah, we get here. As you can see here, this is data after we get this, and okay, and I will edit this by just like 240. Okay, and you can see here this is 0 by the time and until 240. Okay, if I get the total discharge and discharge capacitor, we get the graph just like this. Okay, I will show the the real graph that same in the multisim. So I get this back and I input the data from here. No, sorry. Capacitor transient, and get the data from here until for 0. Yeah, this is our graph. Okay, and edit same like that and 240. Okay, as you can see, it will be changed here, and this is a real graph for the parallel capacitor transient. Okay, so this is real, just like in the multisim. So if you want to I want to show you how from the graph 100 kilo ohms 12 volt capacitor series, get a graph. Okay, just like this. So we get to the parallel, no, capacitor. Okay, 1K series capacitor, just like the multisim here. So as you can see, this is a series capacitor. This is a real graph. Okay, I will get bigger here. So just like in the multisim, so here we get charge and discharge, and this is charge and discharge. This is a discharge. So if I run back this, it's same like this. Okay, it's the same. It's the same for the graph, and here you can see here this is a graph after we get the data from here by using the formula. So the formula is forecast E2. E2 came from here. This is E2, and offset B2 until B72. B2 from here until here. So how I get this formula is from here we're using the forecast A2 offset the B2 here until the 62, because you see here this is until 62, and just like this, match, we need to match, offset back, match, and -102. This is a formula. So if I get this, I will get a 0, and I will get the data I pull here until here. So this actual data from the formula here. So we get this is division per 0. So all I need is get this data and put here. Okay, and after that I get the graph just like this.